Hi there, I got a couple of questions about the Module 5 assignment. So I just wanted to clarify a couple of those points that I got the question about. Before we get started, I just want to address again the hypothesis. So let's go ahead and read this just real quick. You have been hired by the regional real estate company to help them analyze real estate data. One of the company's Pacific region sales people just returned to the office with a newly designed advertisement. It states that the average cost per square foot of his home sales is above the average cost per square foot in the Pacific region. He wants you to make sure that he can make that statement before approving the use of the advertisement. The average cost per square foot of his home sales is $275. In order to test his claim, you collect a sample of 1,001 homes from the Pacific region. So really quick, before we talk about the hypotheses, let's talk about the sample size. So it does kind of oddly worded. The idea is that you're pretending that that Pacific data, that tab where it's got, or that not the tab, all the data from the Pacific region, which is 1,001 observations, you're acting as if that's your sample. So go ahead and just use that entire data set and treat it as if it's a sample of the Pacific region. So that's one question that I got. The second thing I want to talk about just real quick are the hypotheses. So let's go back to the announcement that I posted this morning, just really quick. So when we say that we are testing to see if the salesman's price per square foot is more than the rest of the region, we're actually testing to see if the region is less than 275 because he's claiming his is 275. So we want to know, is it true that the Pacific region mean price per square foot is less than 275? So that goes to this hypothesis right here, where right here we have mu is equal to 275 is the null, and the alternative hypothesis is that mu is less than 275. The reason this is important is if you set up the hypotheses incorrectly, you will get the wrong answer. And it's important. I want to make sure you guys have that all set up correctly. So Dr. Powers did go through in the video about how to find the p-value. But one thing it does ask down here is calculate the p-value, describe the p-value, and test statistic in regard to the normal curve graph. Now, I'm going to show you just an example of what they mean. When they say normal curve or T or student's T distribution, whatever, we're basically just looking at a basic bell curve like that, where you have it centered at a mean. And in this case, it's just 0. Okay, so we're just going to say that this is at 0. And let's just say I'm going to give a hypothetical test statistic, that T-stat. I'm not going to go into too much detail because you guys all should have similar answers, if not exactly the same. All right, so the test statistic, let's say that your test statistic, your T-stat, is equal to, let's say, -3. Let's go with -2. Because -3 is a very extreme value. Let's just say it's -2. And you might get a very extreme value. That's okay. So you might get a crazy negative or a crazy positive. But I'm just going to show you this for illustration purposes. So let's say that our T-stat in a hypothetical hypothesis test is -2. And we're doing a left-tailed test. That would mean that our p-value is here. It's the probability of getting an observation that is as extreme or more extreme than your test statistic. So since we're doing a left-tail test, in this case, that means that the mean is less than, in this case, -2, for example, at any value equal to any value, sorry, not 0. Okay, so the p-value, because this is a left-tail test, is this way. All right, in a right-tailed test, let's just look at that real quick just for information's sake. A right-tailed test would be something like this. The p-value would be over here. Okay, so that's all they're looking for. You don't have to just, it would be easy though to go ahead and just draw a little simple. You could probably Google even basic normal distribution or T-stat, or even pull it from like a screenshot in the book, as long as you make sure to cite it. Just make sure that you understand this, that when we're looking at a left-tailed test, that p-value is this area over here. That shaded area is your p-value. That's the shaded area. That's terrible. There we go. All right. So those are the 2 questions I got. If you have any other questions about this or anything else, let me know and I'm happy to help. All right. Good luck this week, guys.